Hi, in this video, I'm going to talk about a statistical solution to the Newton's long-elusive three-body problem. In the recent issue of the prestigious journal Nature on 18th December 2019, Nicholas Stone from the Hebrew University in Jerusalem of Raka Institute of Physics and Nathan Lee from Universidad de Concepción of Chile have reported a very interesting solutions to the long elusive three-body problem which has been confounding scientists for over 300 years. Right. We all know that Newton established a new way of mechanics which is now called classical mechanics. This classical mechanics is basically based on the ideas of Isaac Newton, in which his laws of motion has helped us to understand a lot about cosmic objects, planetary objects around us. For example, the sun, the earth, the moon, and so on and so forth. It has helped us to send rockets and satellites into space. It has also helped us to fight enemies at the war by using missiles. But that's not all. Newton's equations of motion work very well as long as the objects involved are only two in number. For example, sun, the earth. We all know the earth goes around the sun. But when you bring in the third object, which is the moon, for example, then moon in turn goes around the earth, and therefore the entire system of these two objects go around the sun as well. Now, Newton's equations of motion become insufficient to solve such a three-body problems. Even this one is not very complicated if you think of three-body systems where all the three objects would be of same mass, and if they are at equidistant, similar distances rather from each other. Under such circumstances, the system is no longer deterministic. Newton was considering all systems in the universe to be very deterministic. That is, if the initial conditions are known, such as, for example, the position and velocities of the objects initially, then Newton was able to guess the position and the trajectories of the objects at any future time. So, in his worldview, the universe is deterministic. The universe follows what is called a clockwork system. So, precisely all things are predictable in this universe. So, his universe was entirely deterministic. But when he tried to solve the three body problems, he understood that things are not so easy. In fact, even 200 years after Newton, around 1890, Henry Poincaré concluded that it seems impossible to solve three body systems analytically because getting an analytical solution to three body systems seemed impossible even at that time. And then, 350 years after Newton, still this problem has been confounding scientists without any analytical solution. Now, several other approaches have been taken by scientists to solve this problem, such as, for example, numerical integration approaches. Richard Montgomery, for example, gave one interesting solution where the orbit of the three objects follows what is called an eight path. It looks like the number 8, where the three objects chase each other. One object goes like this, for example, the other one, and the third one is going like this. So this kind of objects chase each other and form a path. But this is not for a system that is non-hierarchical, because here the objects are not of same size, and the distances that they maintain need not be of similar distances. Whereas when we go for non-hierarchical systems, that is systems in which the objects are of different sizes and different masses at different distances, then this problem becomes very nearly impossible to solve analytically. So numerical solution approaches have been tried, as well as the newly discussed statistical solution to the three-body problem by these two people. So this work assumes a lot of significance in the sense that this work does not provide any exact solution to the three-body problem as such, but the approach that has been taken in this work is a statistical approach. What do we mean by statistical approach? Statistical mechanics tells us that when you consider a large number of systems of similar properties, then one can predict a lot of their behavior, which happens to be collective behavior of the systems. So then one can kind of narrow down and say that if these are the conditions, initial conditions, then the system would behave in this way, statistically at least. So that has been the approach taken here by these two scientists, and to arrive at a statistical solution to three-body problem. And therefore, this has opened up, I would say, a lot of new hopes because, for example, some cosmological objects, such as, for example, binary stars and black holes, it is very interesting because typically over the last 200 years, people have believed that when such three body systems are formed, eventually one of the three objects is ejected out of the system, and then it becomes what is just called a binary system, where the objects go around each other in a common around a common center of mass. This is what happens in such systems. So many binary stars and other objects have been observed, and they all seem to follow something similar to this. So the systems reduce to from a three-body system to a two-body system, and if at all the new solution, new way of looking at the problem uh, works out, then one could say that even in, for example, a system of three black holes, if one of the black hole gets ejected out of the system and the remaining two black holes forms a binary system of black holes, then the kind of waves, the gravitational waves that such a massive system could produce could be felt in remote corners of the universe, and therefore on Earth we have a very good chance of even detecting such gravitational waves generated by neutron stars and black holes. Such indeterministic systems are called chaotic systems in the sense that if the initial conditions are altered even slightly, then the system's course completely gets altered. For example, in chaos theory, there is a well-known effect called a very popular effect called butterfly effect, whereby a butterfly fluttering its wings in some remote corner of the world can very well affect and trigger a tsunami in another corner of the world. So this is kind of part of the possibilities that exist in such a chaos theory, and therefore three-body system is definitely a chaotic system in that sense, and therefore determining the future course of such a system becomes highly improbable. In that context, approaching this three-body problem via the statistical solution route is a brilliant idea, and this work assumes a lot of significance in that sense. Thank you.